Hi everyone, today we're going to be covering day 2 of trigonometry, complements and cofunctions. So let's get started. The first question is, what does it mean to be complementary? Something that you have reviewed in geometry. Complementary angles are two angles that have a sum of 90 degrees. So what that means is if I have an angle of, let's say, 40 degrees, the complement to that would be 50 degrees. It would be 90 minus 40, which is 50. Okay. Complements, again, could be, let's say I'm thinking of a 30-degree angle. Its complement would be 60 degrees because 60 is what 90 minus 30 is. Okay. So those are complementary angles. So what we're going to be talking about right now are what we call cofunctions. For this part of the video, you're going to need to use a calculator. So what I'd like you to do is to pause the video after and work out what sine of 25 degrees is, cosine of 25, and I want you to work out all of these values. So you're going to use your calculator depending on which one you have, and figure out what these values are. Please round to 4 decimal places. So for example, if I'm trying to find sine of 25 degrees, I'm going to go 25 sine or sine of 25, again, depending on what calculator I have. And I would get 0.4226. And so that value, see, I rounded to 4 because after 6 would be a 1. And so I'm going to round to 4 decimal places. And each one of these, I'm going to fill out all of these. Make sure that you are in degrees. And when you're done with finding the values for all those, restart the video. So hopefully you went through all of the functions here, sine of 25 degrees, etc. And please verify, take a moment and verify your answers with mine. And what you're looking for are what we call our cofunctions, okay? Because cofunctions are equivalent values, so they're equivalent. So basically, day 1, the other day when we did our introduction to trigonometry, we talked about 30, 60, 90 degrees. So across from the 30 is 1 to square root of 3. And across from the 60 was root 3. And that meant that was my 30. So that's your 1. And this is your 2. If I wanted to find sine of 30 degrees, that's going to be opposite over hypotenuse. That's 1/2. And if I wanted to find cosine of 60 degrees, remember 30 and 60 are complementary angles. Sine of 30, cosine of 60 are cofunctions, meaning adjacent over hypotenuse, they're going to have the same value. So if 1/2 is equal to 1/2, that means that if these are equal, then sine of 30 degrees is going to equal cosine of 60 degrees. Okay, those are my cofunctions. Likewise, when I'm working these out, you'll notice that, see here, sine of 25 degrees. Well, this should be the same as cosine of 65. Those are what we call cofunctions. Likewise, cosine of 25 degrees is equal to sine of 65 degrees. Tangent of 25 degrees should be equal to cotangent of 65 degrees. Cosecant of 25 degrees should be congruent or equal to secant of 65 degrees. Okay, so these are what we call our cofunctions, and remember these values, cosecant, secant, and cotangent, these stem from our reciprocal functions, meaning cosecant of a value is equal to 1 over sine of that same value or angle. Likewise, cotangent of an angle is equal to 1 divided by tangent of that angle. And lastly, secant of an angle is equal to 1 divided by cosine of that angle. So those are my reciprocal functions. So cofunction identities are these, just what we just said. So if I had sine of an angle, that's the same thing as saying cosine of 90 degrees minus that angle. So for example, if I had sine of, let's say, 20 degrees, that's the same thing as saying cosine of 90 degrees minus 20. And so that means that sine of 20 is equal to cosine of 70. And these right here are my cofunctions. And so these ones are the obvious: sine, cosine, cosine, sine, tangent, cotangent. These are maybe not so obvious. Cosecant is equal to secant of 90 minus theta. Secant of theta is cosecant of 90 minus theta. And cotangent, I think those are the obvious, is cofunction with tangent. So given these values, so a new example, given that sine of 18 degrees is this, okay, you have this first value. You also know that cosine of 18 is equal to this value, and tangent of 18 is equal to this value. And your job is to find the 6 trig functions of 72 degrees, none of which I have, I just have 18. So a little hint, use your reciprocal functions and your cofunction identities. So pause a moment and pause the video for a moment and try to write down the ones that you know. And what you're going to start off by doing is, because you're trying to find the 6 trig functions of 72 degrees, okay? You would start off by saying sine of 72 degrees. You're going to go cosine of 72, tangent of 72, cotangent of 72 degrees, cosecant of 72 degrees, and secant of 72 degrees, okay? So pause the video for a moment and try to write down as many of these as you know or you can, and then restart the video and when you're finished. So hopefully you went through this. Sine of 72 degrees. Okay, when you're doing these, I personally always start off with what I know regarding my cofunctions, okay? So for example, ignoring the numbers, the values here, because this is a thing where you are not allowed to use or just say no calculator. You are not to use a calculator, so no calculator. So without using a calculator, how are you going to find sine of 72 degrees given these? Well, remember your cofunction identities. So you know that sine of 18 degrees is equal to cosine of 72. You also know that cosine of 18 degrees is equal to sine of 72 degrees. And lastly, you know that tangent of 18 degrees is equal to cotangent of 72 degrees. So realistically, we already have some of these values. For example, sine of 72, well, that equals cosine of 18. I have cosine of 18. So that's going to be 0.951. Cosine of 72, well, that equals sine of 18, and I have that. And so that's going to be 0.3090. Tangent of 72, I don't have, but I do have cotangent of 72, which is tangent of 18. So cotangent of 72 is going to be 0.3249. So I have those three. Now, remember, now that I've used my cofunction identities, now I'm going to work on my reciprocal identities or functions. So remember what we talked about in the previous slides, which is that cotangent of an angle is equal to 1 over tangent of angle. Okay, so basically that means that tangent of that angle equals 1 over cotangent. So my tangent, I could write 1 over this, which is 0.3249. Now remember, you don't have a calculator, so you're not going to be working that out. You're just going to write it like that. On another note, I want to remind you of something that we learned in day 1 slides, and that was that tangent of 72 degrees is equal to sine of 72 over cosine of 72. So just a note, another way I could have written this is going to be sine over cosine, and that would have been 0.3090 over cosine, which would have been 0.951. So I could have said that. And then for this problem right here, for cotangent, I could have taken this value here and flipped it upside down, meaning this one here could have been 0.951 divided by 0.3090, okay? Cosecant is, remember, the reciprocal SC, the reciprocal of sine. So this one right here should be 1 divided by 0.951. And lastly, secant is the reciprocal of cosine, and so that's going to be 1 over 0.3090. Okay? Without a calculator, that's as far as you're going to get. Okay? So just to recap, given that cosine of theta is equal to 0.3, another way of writing that is cosine of theta equals 3/10. Find your angle, put yourself there, okay? A lot of people like to just draw a little fake self there. Cosine is adjacent over hypotenuse. Now, before I can find the other 5 trig functions for this and theta, I actually need to know what my third side is. So I'm going to use Pythagorean Theorem. I'm just going to call that x for right now. So x squared plus 3 squared is equal to 100 squared. So x squared equals 100 minus 9, which is 91. So x equals the square root of 91. So this value right here is the square root of 91. So the 6 trig functions I'm given, besides cosine, that I was given that, would be sine of theta, cosine, tangent of theta, cotangent of theta, secant of theta, cosecant of theta. And I think that's all of them. So sine of theta is opposite over hypotenuse, so that's going to be the square root of 91 over 10. Tangent of theta is opposite over adjacent, so that's going to be root 91 over 3. Cotangent of theta is going to be this value flipped, so it's going to be 3 over root 91. Keep in mind, you're not going to leave a root on the denominator, so you're going to multiply by root 91 over root 91, which is 1, because you're allowed to multiply by 1 to simplify the problem, meaning I multiplied by root 91 over root 91, and I got 3 root 91 over 91. So that's that value for this one. For secant is reciprocal of cosine, which is way up here. So that's going to be 10 divided by 3. And cosecant is the reciprocal of sine, and that's going to be 10 over root 91, which is going to be 10 root 91 over 91. Now, lastly, we need to find theta. Now, I can pick any one of these to find theta, but remember, I'm just going to start off with cosine of theta is equal to 3 over 10. So theta is equal to arc cosine of 3 over 10. I need to work that out. So let's see here. Arc cosine of 3 divided by 10. So 3 divided by 10, of course, is 0.3. You take arc cosine of that, and that's going to be 72.5 degrees. So theta is about, because I'm rounding off, that's why you have the approximations, 72.5 degrees. Okay? So we found all the 6 trig functions, including theta. The last 3 problems are to find the exact value. Remember, exact values are only used on special right triangles. Also, including 90s. Okay, so like 30, 60, 90s, 45, 90s, 180, 270, 360, etc. Those are all going to give me an exact value. So cosine of 30, it's completely fine to, there's 30 degrees here. Opposite 30 is 1, 2, square root of 3. A lot of people will draw a little right triangle here every time they try to find one. And a lot of people will memorize these because you should. So cosine of 30 is going to be adjacent over hypotenuse. So that's going to be root 3 over 2, which is adjacent over hypotenuse. Tangent of 45, you know, is 1. But I'm going to just draw my right triangle. 1, 1, square root of 2. Tangent's opposite over adjacent. Okay, opposite over adjacent. So that's 1 over 1. Secant of 60. Now remember, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, which means secant is going to be hypotenuse over adjacent. Okay, so I'm going to draw my little 60-degree angle. Here's 60. Across from the 60 is root 3. 2 is across from the 90, and 1 is across from the 30. So for this problem, secant is going to be hypotenuse over adjacent. So this value is going to be 2 over 1, which is 2. Okay, so I believe that I have a worksheet for you right after these two problems, and then you're going to have some time for that. So these last two problems, this one, I think the question's a little bit off. You also have to solve the following triangles for x. For this problem, x is just 90 minus 25. So I think they were trying to say solve the triangle and find x. But 90 minus 25 is going to be 65 degrees, and so that would be it. For this one, though, you're trying to find x, which is the height. If you were to split these triangles up, you would have this one, which was 65 and x. But in order to find x, you actually need an additional side. So for this problem, I think I would start with the biggest triangle, okay? And I would say, well, here's 25, here's 70, and this is x. And so you're going to say sine of 25 is equal to x over 70. So x is equal to 70 times whatever sine of 25 is. And then, so x is equal to sine of 25. So you would need to work that out. So you'd go 25 sine, and that's 0.4226. And then you would multiply that by 70. So it'd be 70 times 0.4226. And so that number times 70 is equal to 29.6. So x is approximately 29.6. And so that would be the height for this value right here. Okay, let's get started on the worksheet. Thanks for watching.